Okay, so section 4.2 should be a review of Algebra 1. Adding, subtracting, multiplying polynomials. When we get back after a break, what operation did I leave out there? Dividing. So we'll do dividing when we get back. I don't think you really did dividing polynomials in Algebra 1, but you did this stuff. You might see some stuff that's a little different than what you're used to, but this is just all about getting the stuff done, and whatever way you choose, you can do it. So I'm going to show you how to add polynomials vertically or how to add them horizontally. There's two different formats. When you do it yourself, you can do whatever format you want. So to add it in a vertical format, we're going to take 3x cubed plus 2x squared minus x minus 7. And underneath it, we're going to add x cubed. So what I'm going to do is I'm going to line up the x cubed with the 3x cubed because they are like terms. What do you mean by move them around? You mean the x cubed? Like I could if I needed to, because it's addition and we can add in whatever order. Then we'll have minus 10x squared next. And then there isn't an x term for this one, so I'm just going to leave it a big space. And then we have a plus 8. If I want, I could put like plus 0x in there. That's not something I have to do, but nothing's going to line up with that. So remember, like terms have the same variables to the same powers. Same variables to the same powers. That's when you're allowed to add them, and you just add the coefficients. So when I have it all lined up like this, I can add 3x cubed plus one more x cubed, which gives me 4x cubes. I've got 2x squareds, and then I'm taking away 10x squareds, which leaves me with a negative 8x squared. I have a negative x, and I'm doing nothing to it, so minus x. And then I have a negative 7, but I'm adding 8, so plus 1. That is a vertical format. I prefer vertical format. There's also the horizontal format. This would be like 9y cubed plus 3y squared minus 2y plus 1 plus negative y squared plus y minus 4. So in the horizontal format, you have to determine what to do to get rid of the parentheses first. So what do I do if I'm getting rid of the parentheses? What do I do here if I'm getting rid of the parentheses? Does the plus sign change anything? Oh, okay. Does it? Do I need the parentheses? When would I need the parentheses? If I have something on the outside, I do have something. I have a 1. Jackson? Yeah, if it was a subtraction, I definitely have to distribute that negative number in. But this is a positive one that doesn't change anything, so I don't really need these parentheses. But that's what the horizontal method has. Now, what I do when it's in horizontal form is I like to make pretty pictures. So I say, well, 9y cubed. I'm going to look for a friend for 9y cubed. Does it have any like terms? Nope. All alone. So I go ahead and write that one down. And then 3y squared. I'm looking for a like term with 3y squared. And over here, I have a minus 5y squared. So I will add those together, and I will get a minus 2y squared. Then I've got my minus 2y. I've got a plus 1y. And that gives me negative 1y, which I don't write the 1. And then finally, I've got this plus 1 and this minus 4, which gives me negative 3 or minus 3. And that's the horizontal method. All right. Subtracting polynomials vertically and horizontally. So same stuff, just subtraction. So vertically, 2x cubed plus 6x squared minus x plus 1. Oh, nope, I'm already wrong. I didn't read the question. You should probably read the question before you start writing. Do you know why I'm wrong? Did you guys read the question? I'm wrong. Corey, why am I wrong? The vertical format comes when I write the second equation in there. Jacob, why am I wrong? This is the key word. From means this one's got to be second. Put it in the wrong place. Oh, let's erase it. And you know what? I do that every single year, and then I remember later, oh, yeah. Because of that word from, that means I'm going to start with 8x cubed minus 3x squared minus 2x plus 9, and I'm going to subtract 2x cubed plus 6x squared minus x plus 1. Now, because I am subtracting, I have to subtract every single term. Subtraction is the same thing as adding a negative. They're the same thing. So what I'm going to do is I'm going to change this into adding, which means I will change all of the signs for that polynomial. So if I draw this little line here, I have to change all the signs. If I draw the line, I got to change the signs. Draw the line, change the last signs. All right, now I've changed it into addition, which I've already showed you how to do. So we get 6x cubed minus 9x squared. Negative 2 plus 1 is negative x, and then plus 8. So before we start the next equation, we see, or the expression, we see the word from. So subtract from. So I'm going to take 2z squared plus 3z, and I'm going to subtract 3z squared plus z. Oh, why am I doing this vertically? Sorry. Other way. I'm going to subtract 3z squared plus z minus 4. And because we have this minus sign out here, this is the same thing as a negative 1 being multiplied. We need to distribute that negative 1 in. So we have 2z squared plus 3z minus 3z squared minus z plus 4. So we're basically changing all the signs. Then we will collect like terms. So I've got 2z squared minus 3z squared, which is negative z squared. Got a 3z minus z, so plus 2z. And then I have that plus 4 all by itself. So you can determine if you want to do horizontal method or vertical method, your choice. Either is fine. There's some practice, but I'm just going to keep going because you guys did this in Algebra 1. Next is multiplying polynomials vertically and horizontally. Multiplying polynomials vertically and horizontally. Man. So I will tell you, I almost never do the vertical format. I'm going to show it to you, but then I'm going to, next to it, do what I would do as my backup for the vertical format. I'm going to put that on the other side, the backup. But I'll show you the vertical format. Negative x cubed or squared plus 2x plus 4, and then x minus 3, and we're going to multiply these. This is like old school, elementary school multiplying here. You start with the negative 3, and you multiply that negative 3 to the 4. You do not need to carry anything. You can put the whole minus 12 down there. Then we do negative 3 to 2x, which is minus 6x. Then you do negative 3 to negative x squared, which is positive 3x squared. Okay, and then I'm going to do the same thing with the x. I'm going to do x times 4, which is 4x. But you remember in when we did this stuff before, there'd be like a 0 in this term. You know, you move it over back in elementary school. All right, then we do x times 2x, which is 2x squared. And that 4 is positive, so I need to just have a plus sign in front of it. And then I do x times negative x squared, which is negative x to the 3rd. And then after we did this in elementary school, what did we do between these two rows? We added them. So they should be already lined up. Negative x cubed plus 5x squared minus 2x minus 12. Okay, the other format, which isn't covered here, but I think people like a lot better than the vertical format, is using the box. I think a lot of people like the box to multiply. So I'm going to show you it this way as well. So if we're going to use a box to multiply, since we're doing 2 terms times 3 terms, I'm going to have a 2 by 3 box. And then outside of my box, like a grid, I should call it a grid. Anyway, outside of this, I've got x and then minus 3. So I'm separated in the terms, putting the negative signs where they go. Across the top, I've got negative x squared, 2x, and 4. And then we multiply to basically find the areas of each box. I'm filling out the grid by multiplying. So in this first one, I'll have x times negative x squared, so negative x cubed. The middle top would be 2x squared. The top right would be 4x. And then the bottom left would be positive x squared. And negative 6x. And then negative 12. And before I finish this, hopefully you can see that both of these methods were almost exactly the same. We're getting the exact same numbers. It's kind of in a different format. To finish this, we look for like terms, usually, but not always. They are on columns, not columns. What is this? Diagonals. Yes, Nina. Yeah, you didn't see my 3 there? Yeah. So then I get negative x cubed, and then I'm going to add together and get 5x squared. Then I'm going to add these together and get minus 2x, and then I have a negative 12 by itself. So we get the exact same answer that we did the first time. different method. You can choose what method you like. And then finally, the horizontal format, which in all honesty, it's used the most in higher level math. You are more than welcome to come to pre-calc and pull out a box and multiply stuff that way. But usually the teachers, because we were never taught this awesome box method, we just go back to what we are used to, and we usually use the horizontal format. But there's nothing wrong with using the other format. It's just, this is what I'm used to. This is the way I grew up. They didn't have fun stuff when we grew up. I know I had a hard life. Okay, so to use the horizontal format, this is where I'm going to think about our distributive property, which we should already know the distributive property. And I'm going to start by distributing only the y. And I always color mine so I can follow along with what I did. I'm going to distribute only the y. So I'm going to get 3y to the third minus 2y squared plus 2y. And then I like to teach my color. And then I distribute only the 5. And when I do 5 times 3y squared, that's 15y squared. So I purposely put it underneath my 2y squared. Then I get 5 times negative 2y, so minus 10y. And I get 5 times 2, so plus 10. Just going to add that up. 3y cubed plus 13y squared minus 8y plus 10. All three methods will get you the work, or like the answer, the same, basically the same way. We are distributing one number at a time. And then adding together the like terms. All right. What happens if you have to multiply 3 things? We have to multiply 3 things. So I'm going to go and ask you a really easy question. How do I multiply 5 times 1/7 times 7? That's 3 things. How do I multiply 5 times 1/7 times 7? Fifth grade math, help me out. Sophie, you know what it is?
You put a 1 on the bottom.
Of what?
Like 5 and 7.
Sure, we can. We can do that. Jaden. Okay, you guys are making this way too hard. Let me give you a different question. This is not, I'm not looking like, how do I multiply fractions? Sorry. Yeah. Yeah. I'm gonna ask you a different question now. Let's do gosh. Okay. 10 times 27 times 10. How do we multiply this one? What do you mean? Multiply what? Oh, am I allowed to multiply the first and the last one together? Am I allowed to do that? So there's a property in math called the commutative. You don't have to write it down, but it's called the commutative property. But that allows us to rearrange multiplication or addition. So if I multiply the tens together, I get 100, but that's not my answer. So now what do I do? 100 times 27 is 2,700, right? What we did is we multiplied 2 of them together first. I don't like the number because that makes you think there's a number there. Multiplied 2 together first. Took that product and then multiplied the third one. That's what we did. You cannot multiply 3 things at the same time. You can only multiply 2 things together. So because of that, how do we multiply 3 binomials? You can't multiply 3 binomials at one time. You can multiply 2 of them together and then take their product to multiply by the third one. So as I'm writing these down, does anybody, and I do not care, does anybody have a preference of the first 2 that I should multiply together? Speak louder because I don't know which preference is. If there is any preference. No? Okay, then I'm going to choose. So since these 2 are both positive, I think I'm going to go by multiplying these together first. Take a moment, multiply those together. Practice your multiplication. Multiply those together, any method you choose. Unfactor those, because that's what multiplying is. Opposite of factoring. Multiply those together. Any method you choose. She should see evidence of your multiplication. Aya, why don't you take a note? Do you know this stuff already? So what method did you use? Somewhere else? Okay. Use the box. What method are you using? Box. You use the distributive? Box. Box. Distributing. Use distributive property, use distributive, you can go in the box. Which method? Oh, you didn't do it. What method did you use? You draw the box because you missed some terms there. Distributive. Okay, why don't you try the box method because you're not doing that one correctly. Okay. Those of you, the majority of you that did the distributive property, you did it just fine. So I'm going to show the work for the box method because I had a few people get this wrong. So if I'm doing the box method, I'm doing a binomial times a binomial, 2 terms. I've got an x plus 5 and I've got an x plus 4. You can put the plus there if you want. It doesn't really matter. X times x is x squared. X times 5 is 5x. X times 4 is 4x. And 4 times 5 is 20. When we add those together, we look for like terms. When we add those together, we get x squared plus 9x plus 20. So we get a trinomial. Once you've done that, I did see some of you go further. Once we've done that, we do need to multiply the x minus 1 times the product, x squared plus 9x plus 20. So if you want to do a box method, you can. If you want to do the distributive method, that is also fine. Just walking around the room, people were struggling the most when they didn't show work. So I'll make sure we show work. And again, just saying, you guys, I most likely would always do the distributive property, but that's just because that's what I'm used to, the way that I grew up. X cubed plus 8x squared plus 11x minus 20. Question? Did I make a mistake? Did you make a mistake? 20 minus 9? Would you put 9? Would you say? Oh, okay. So that's how you multiply 3 binomials. All right. The last page here talks about special product patterns. And these aren't things that you would have to know. They're just shortcuts that are always happen. For example, I know the square of a binomial pattern. I have to multiply out so many squares of binomials that I just know this pattern. The pattern is, if you are squaring a binomial, you square a squared, you square b squared, and you put it at the front and the end, and then the middle term is twice a times b. I just know that, so I always multiply it out that way. Another one, sum and difference. If you've got one a plus b and one a minus b, if you do the distributive property or the box method, the middle terms will always cancel out, and you'll be left with a squared minus b squared, which when we were factoring was called difference of squares. So these are patterns where if you recognize them, you can use them, but they are not crucial to passing this class. So if you don't learn the patterns, that's not a big deal. Looking at this, I would like you to try 5, 6, and 8 on your own. And 7. 5, 6, 7, and 8. Let's do it. 5, 6, 7, and 8. You're multiplying binomials. 5, 6, 7, and 8. Whatever method you prefer. 5, 6, 7, and 8. Try them. I'm going to go ahead and turn off the video. If somebody's watching the video at home and would like to know these answers to see if they got them right, just send me an email.